Hello and welcome to this video on uses of the motor effect electric motors for GCSE Physics and Combined Physics higher only, and don't forget to like and subscribe. In between two permanent magnets is a magnetic field and its direction is north to south. If a wire in a circuit is placed in that magnetic field and the circuit is switched on, then the wire will have a magnetic field around it. The two magnetic fields interact and this causes a force that will make the wire move. In this example, the wire will move upwards. This is the motor effect. For this to happen, the direction of the magnetic field of the permanent magnets, the direction of the current and the direction of the force need to be at right angles to one another, and this is shown by Fleming's left-hand rule. If a coil of wire is placed in a magnetic field, it will rotate for a quarter of a rotation. In this diagram, I have simplified the coil. But essentially it comes into the magnetic field, moves around and around for a number of turns and then comes out the other side. The rotation happens because the current is towards you on the purple side of the coil and away from you on the orange side of the coil. On the purple side, the current's direction causes an upwards force on the wire, and you can see this if you use your Fleming's left-hand rule. On the orange side, the current's direction causes a downward force on the wire, and again this can be shown using Fleming's left-hand rule. The two opposing forces cause the coil to rotate. The coil will rotate until it is in the vertical position. This is where the forces on the wire are in the same plane, so there is no more turning effect. These are summary diagrams so that you can see what is happening at each stage. Opposing forces on the coil of wire cause the rotation until the forces are in the same plane. At this point, there can be no further rotation. To get the motor to continuously turn, it needs a redesign which includes a piece of equipment called a split ring commutator. This allows the motor to continuously turn and without getting the wires tangled. Every half term, the commutator switches contacts on the external circuit. This swaps the direction of current in the coil. The switching of the current maintains the direction of the force on each side of the coil, and so the coil can keep rotating. And that's all for this video. Thank you so much for listening.